Hi friends, once again welcome back in our educational channel, that is Precise Electronics. Friends, in today's video lecture we are going to study differential amplifier. What is differential amplifier? It is the first and second blocks of operational amplifier. The first block is first stage differential amplifier, while second block is a second stage differential amplifier. First block has two inputs and two outputs, while second block has two inputs but only one output, and that output is connected to third block, that is level shifter and emitter follower. Differential amplifier. It is perfect balanced amplifier. It has two input signals. The circuit diagram of differential amplifier is now going to be displayed on your screen. From this diagram, it is clear that there are two transistors. There are two transistors T1 and T2 having same number or same value are used. So transistor T1 and T2 are of same number or of same values. Emitter of transistor T1 and T2 are short circuit and they are connected to negative supply minus VEE through RE, or it is R3. In some cases it is considered as R3 or it is considered as RE. RE stands for the emitter resistor because it is connected to the emitter of transistors. Then collector of transistors are connected to the plus VCC through resistors R1. In this case, the two resistors, once again the same resistance values are used. So R1 connect the collector of transistor T1 and T2 to plus VCC. The base of transistors are connected to input signals V1 and V2 through input resistors R2. V1 is connected to the base of transistor T1 through resistor R2, that is the base resistor. Similarly, the input signal V2 is connected to the base of transistor T2. Once again, the R2, that means the same value of resistance, are used as a base resistors, through which the input signals are connected to the base of transistors. Between the collector terminals, the output terminals are connected. Collector of transistor T1 and collector of transistor T2 delivers the output signal. That is the circuit diagram of differential amplifier, in which the two sections, that is sections of transistor T1 and section of transistor T2, these two sections are perfectly balanced because the same number of components are used. That is the circuit diagram of differential amplifier. Now we are going to apply the input signals. If two voltages of equal magnitude and sign are applied to input terminals, that means V1 is equal to V2. The both signal having the same magnitude and same signs are applied to the base of transistor, due to which transistor T1 and T2 conducts, and in this case the current flowing through collector of transistor T1, that is IC1, and current flowing through transistor T2, that is IC2, are of same values. That means IC1 is equal to IC2, and hence there will be no output potential. That means output is 0, and this state or this mode is a perfect balance mode. That means the amplifier is in perfect balance condition. Output potential across the output terminal is 0. But if base of T1 is more positive compared to base of T2, that means the biasing potential applied to transistor T1 is more than the biasing potential applied to transistor T2. So obviously T1 conducts more heavily than the transistor T2, and hence the current flowing through collector of transistor T1 is now more than the current flowing through transistor T2, and due to which the balance condition of amplifier is now get disturbed, and in this mode we are getting some output signal, and this mode is known as differential mode of amplifier, and these signals applied to the transistors are known as differential input signals. The output is differential output, so it is a differential mode of circuit, differential mode of transistor. If Now we are going to find out the expression of gain. If V1 and V2 are two input voltages applied to base of transistors T1 and T2 in such a way that V1 is equal to minus V2. V1 is equal to minus V2 means the magnitude is same but sign is different. V1 is positive, V2 is negative. So obviously transistor T1 conduct more faster than transistor T2. Transistor T1 conduct more heavily than transistor T2. The gain of the amplifier is given by gain, that is A, and it is AD. D stand for the differential gain. So it is AD, A suffix D. A for the gain and D for the differential mode. So AD is equal to V output upon V input. It is gain is given by, it is a ratio of output to the input. So V output upon V input, that is our equation number 1. But V, that is Vi, that is the input, that is equal to V1 minus V2, equation number 2. It is a differential mode. So Vi is equal to V1 minus V2, that is equation number 2. But V1 is equal to minus V2, or we can also state that V2 is equal to minus V1. V2 is equal to minus V1. By substituting this value of V2 in equation number 2. What is equation number 2? That is Vi. Vi is equal to V1 minus V2. By substituting the value of V2 in this equation, we get Vi is equal to V1 minus, in bracket, minus V1, because V2 is equal to minus V1. So V2, V input is equal to V1 minus, in bracket, minus V1. So minus minus becomes positive. So V input is now equal to V1. V input is equal to twice that of Vi, twice that of V1, or twice that of V2. We are consider V input as twice that of V1. By substituting this value of V input in equation number 1. What is equation number 1? That is AD is equal to V output upon V input. Now we are going to substitute the value of V input in that equation. So we get AD, A suffix D, is equal to V output upon 2V input. And this is our final equation to find out the gain of the amplifier in differential mode. So differential mode of the amplifier is given by V output upon 2 times that of V input. Differential gain, or gain of the amplifier in differential mode. So it is a differential mode gain. Now, if the input signals having same sign and same magnitudes are applied, that means V1 and V2 both are of same magnitude and both are of same sign. So V1 is equal to V2. So in this case, transistor T1 and T2 get the equal biasing potential as the current flowing through transistor T1 and current flowing transistor T2, that is the collector currents IC1 and IC2 are same, hence the output will be 0. But it is a theoretical concept. In actual practice, there is a slight mismatching in a transistor's parameters as well as the resistance value, because resistance is given, there is a tolerance plus minus 5%, plus minus 10%, or plus minus 20%. So the value of two resistors will never same. There will be a slight mismatching. So as the parameters of transistors are slightly different, if amplification factor of transistor T1 is more than transistor T2 or vice versa, the transistor having more amplification factor conducts more faster than the next transistor, and due to which one of the transistor conducts more faster than the other transistor, and hence the current conduction takes place, the current flowing through IC1 and IC2 is now different. So as IC1 and IC2 are different, there will be some output potential. That means if the input potential is common, a common signal is applied, we are getting a small output potential, and this mode is known as common mode, and the output or the gain of the amplifier in this mode is known as common mode gain. Now we have to find out the expression for the common mode. That means we have to find out the common mode gain. A, that is gain. Now the suffix is C, and C stands for common mode. So A suffix C, that is common mode gain, is equal to, once again the same formula, that is V output upon V input. So V output upon V input, that will be equation number 3. But in this case, as it is a common mode, the common inputs are applied to both the transistors. So obviously V1 is equal to V2. So as V1 is equal to V2, V output is given as V1 plus V2 by 2. It is an average signals. And that is our equation number 3. So V input is equal to V1 plus V2 upon 2. That is equation number 4. By substituting this value of V input in equation number 3, we get A suffix C is equal to V output upon V1 plus V2 by 2. By rearranging this equation, we get AC is equal to 2V output upon V1 plus V2. And friends, this is our final equation for the gain of the amplifier in common mode. So it is known as common mode gain of the amplifier. So common mode gain of the amplifier is equal to 2V output upon V1 plus V2, while the differential mode gain of the amplifier is V output upon 2V input. So friends, that is differential amplifier. The gain of the amplifier in common mode is V output upon 2V input, while the gain of the amplifier in common mode, gain of the amplifier in differential mode is equal to V output upon 2V input, while the gain of the amplifier in common mode is equal to 2V output upon V input. So friends, that is differential amplifier. In next video lectures, we are going to study the parameters of operational amplifier. So friends, keep watching our video lectures. Subscribe our YouTube channel as well as follow our Facebook page. Keep watching these video lectures. Friends, bye. Take care. Once again, thanks for watching this video lecture. Bye. See you in next lecture. Bye.